I'm wearing my favorite tartan shawl today to make a point. I want to talk about the greenhouse effect. Now, this is something that people have a lot of misconceptions about. It is completely different from the ozone layer and ozone depletion. Watch that video, something very different. You know a little bit about the greenhouse effect if you've ever tried to walk across a parking lot barefoot on a hot, sunny day in the summer. You know that it gets very uncomfortable very quickly. Now, what's been happening is that the sunlight has been beating down upon that asphalt, and the asphalt has absorbed that sunlight and has gotten hot. Now, not hot enough to glow. That would be very unfortunate, but definitely hot enough to make your feet uncomfortable. And if you had special heat vision glasses, it would look like that asphalt was glowing because those heat-sensitive goggles would be observing a kind of light called infrared. Now, the infrared is wavelengths that are too long for your eye to see, but you can feel the energy from them on the soles of your feet. So, that infrared light is escaping upward from the hot asphalt. And all things being equal, it would just go back into space. But there's something between the asphalt and space, and that's the atmosphere. More particularly, there are certain gases in the lower atmosphere, in the level closest to the Earth that we call the troposphere. And these gases will absorb infrared. And because they absorb the infrared, they trap that energy in the lower atmosphere and make the lower atmosphere warmer than it would normally be. They act like a blanket or a warm wool shawl. And that act of trapping the energy from the infrared in the lower atmosphere and warming the lower atmosphere where we are near the surface of the Earth, that is what is called the greenhouse effect. And any gas that will absorb the infrared and trap that energy and warm the lower atmosphere is called a greenhouse gas. Now, the most important greenhouse gas on Earth is water. And you already know this, even though you may not know that you know this. In the wintertime, if you go outside on a clear night versus a cloudy night, when is it generally colder? If you think about it, it's usually colder on a clear night. On a clear night, we have something called radiational cooling. That means that the atmosphere doesn't have as much of its blanket on, and more of the infrared can go into space, because those clouds, being made out of water, act as an infrared absorbing blanket. So, water is a very important greenhouse gas, clouds. The second most important is carbon dioxide, and that's the one you hear about all the time. And the reason why carbon dioxide is the one you hear about all the time is because carbon dioxide, the amount of it in the atmosphere, is affected by human activity. Whenever we burn something, we burn gas, we burn oil, we burn coal, we burn natural gas, we burn wood, we are releasing carbon dioxide into the atmosphere. And if we increase the amount of carbon dioxide in the atmosphere, we increase the thickness of that blanket, and we warm the lower layers of the Earth, of the Earth's atmosphere. Now, having it be toasty warm is good. Having it be too warm is not good. And that is where it comes into what's called anthropogenic climate change. If we put too much carbon dioxide into the atmosphere, we raise global temperatures, we affect weather patterns, and that is a bad thing.